Hello, welcome back to Creative Imagineering. This week, computer, initiate startup.
Working. Powering up the workstation.
I'm going to show you how I did this. I hope you enjoy. Hello, welcome back to Creative Imagineering. This week, I've created an integration between Arduino programming, Arduino hardware, a servo, some 3D printed parts, and an ice cream container, okay, and an Amazon Alexa Dot to create a way of starting on my PC either by voice or by a press of a button on my mobile phone wherever I am in the world. So here's how I did it. Okay, so let's have a look now at what I did. The first step was to create a cradle to hold the servo, because in the end there's no software I can use for this because the computer's not running. Okay, so I'm going to need a robotic finger to start on the PC. So you can see here I've made a little cradle. It's measured to fit my servo. Okay, it's just a cheap blue servo from Lazada, and I've got two holes cut in the top here for two buttons. Now normally a PC is started with just one button, correct? Okay, now I've got two buttons wired into the power on pins on the motherboard. One sits on my desktop at the moment because I haven't built the desktop control unit yet. It's a future project. And the other button is actually sitting in this cradle. And there's a servo sitting inside with a robotic finger that presses the button. I'll show that later. But the other button will be connected to an Arduino in the desktop control unit, and it's going to just turn on a fancy light effect. If you remember your original Star Trek series, there were some computers like the scene with the Klingons on this planet. There was like all the people were peaceful like lambs, right? And this Klingon had this desktop control unit in it, which is actually... I'm wondering why a Klingon is using a Starfleet device, but anyway, it was a small unit about 50 centimeters wide, and it had a triangular light bar on top, almost the full length of it, and it was multicolored lights inside. Well, I've got a script here. It's from a tutorial by Michael Maforta on YouTube. Look it up. It's about a hexadecimal counter, and it counts through the hexadecimal numbers by lighting up the LEDs. But when I randomized that, just for an experiment, I suddenly had this random multicolored light sequence just like those desktop computers. So that's what I'm using for that. So that's why I've got two buttons mounted in this cradle anyway. But that'll be a future project that I'll discuss. Okay. So here we are, 3D printing the whole thing. It took a while, but it actually printed a very nice product in the end. I'm using a Creality Ender 3, and I'll tell you what, this printer was a pain in the neck to get it working correctly. In the end, the bed, you know, it had the thin bed overlay on the aluminium bed, on the metal bed, and it warped, and it was causing all sorts of problems with printing. So I bought this tempered silicon glass, I think it's silicon, overlay, and it's working much better. And also changed my filament too. I'm using the Creality brand filament now instead of other brands, and it seems to be working better as well. But yeah, 3D printing is another topic. Let's have a look at the cradle. There's my servo. It's just a cheap servo, and it's designed to come up underneath the cradle. So the two tabs that you see here will be glued underneath front and back. Except when I put it together, I forgot that. I put it through the top. To put it through the top, I had to cut out this front area here. And then when I put it in, I realized this was too high to press the button. So it was just like one of those mental blackout moments, you know. But anyhow, I put it the right way in. I glued the bar back in place. All is good. Okay, it's all very solid. It works fine. So you can see this simple push button in place here, but obviously this here is not really up to the job of pressing the button. So I glued another arm on top with the shaft at the end. That gives a nice rounded finger, shall we say, to press the buttons. So what happens is when this thing powers up, it presses this button and then it swings across and presses this button with a small delay in between. Okay, here we are. I'm starting to get everything together, wired in the servo and did some initial tests. Everything's fine. I'm using a Walls ice cream container. In case you're wondering, it was chocolate chip, vanilla and chocolate. Over here I've got a cheap smart home switch. Now if you're familiar with Arduino, you'll know that the moment you power up an Arduino, it loads and executes the code. So nothing special has to be done here. All I have to do is turn on this switch remotely through Amazon Alexa or even my Google Home downstairs, whatever, my mobile phone, whatever I'm using. Once this switch is on, the Arduino powers up and it sends the instructions to the servo to press the buttons. It's actually really simple. Also over here, this is just these are nylons standoffs that you can buy cheaply online. I got them on Lazada. Look, I live in Thailand, so I'm using Lazada to buy everything. If you're in America or other places, you might be using other sources. Okay. Oh, the power supply here is actually the power supply for my Amazon Alexa, which I'm not using because my Alexa is actually plugged into a USB powered hub. Alright. Okay, so it's connecting up the wires to the switch, and I'm using heat shrink tubing to solidify everything, but please be careful if you're doing that because you can see here I burned it a little bit, so a little bit too much heat, a little bit too much flame. That's something to be careful of. And here I am, I'm starting to put the box together. I've just got one of those little hand drills that modelers use and drilled the holes through. The largest bit was just the right diameter for the threaded shafts on these. And you can see here I've got a long one and I've got a shorter one here just to give a more suitable distance. And I put this connector here, and then I realized afterwards it needs to be on the outside. So it's now on the outside, as you can see. And I'm just using the normal wires that you get in developers kits with Arduino or whatever. So now you've got these nice wire pins on the end of the wires, which make them super easy to use. And you can see here it's just connected up to this conventional connector really easily. Now the whole servo assembly here is glued down onto the back of the ice cream container. And there we go. Testing it out there. It all works nicely. I found a longer USB cord that I had packed away somewhere, and I'm using that. It works really well. You can see I've got a hole cut in the side of the container just to let the wires out. And yeah, that works all nicely. No, Mr. Spock was not on hand to help me. I had to do this myself. There's the lid for the ice cream container screwed up into the top rail inside the cabinet underneath the monitor. See, there's my solid state hard drive there. And unfortunately, some of the brackets I printed them very badly, so these were hollow here. I was still learning how to 3D print, so the settings weren't quite right, so I need to go back and print some new brackets. These are here just to support the cables. But anyhow, there's my the lid. You can see this is actually the desktop, so right above here is the computer monitor. And that's with the ice cream container connected up. In fact, with all the lights out in the room, the red LEDs in there make that container glow beautifully. I like it. So anyway, it's all connected up there. Obviously, this switch is not connected up yet because this button is for the fancy lights on the control unit. Down below, I've got a UPS. Okay, so here's the code that I used. Now, I didn't create this all by myself. I did Google search how to use a servo on an Arduino, and I found a very nice tutorial. I think it was on Instructables, I can't remember now. And on that tutorial, it just gave a very simple instruction on how to swing a servo back and forth. So I took that code and adapted it, as everyone else does, to suit my needs. So some of the code is unchanged, whilst quite a bit of it is changed. So obviously you need basics like including the servo library, you need to define your servo pin, and I created another integer called control loop equals 1, and the whole purpose of that is to make sure that you can see here while control loop equals 1, the whole thing will just run once, okay? Because the void loop, right, the void loop function, that'll keep going over and over and over again. It'll never end as long as the Arduino is powered up. But I only want it to press the finger once, not a million times. So I've got to control that. So that's what control loop does. This while loop will run just once and then it will stop. Obviously I'm creating the servo object and I'm setting it up here. So let's look at this while loop. So while control loop is 1, the first thing it's going to do is center the finger to make sure it starts off in the right position. And there'll be a short delay of half a second. Then it'll swing it across to position 25 and there'll be a short delay of 250. Okay, so this is where it's going to actually press the power on button. Then there'll be a short delay after it does that. And then it'll swing across to the opposite position to press the animation button, which is not wired yet. Obviously, I've got to build that control unit yet. But that's what it'll be doing here. There's another short delay before it returns to the center, back to home position. And then I put a delay of 1 second in there before stopping the servo. You see here, while control loop equals 0. So now, when it comes back around, it's going to ask control loop equals 1. No, control loop now equals 0, so I'm not going to run the code that's inside. So that's just a very simple way to stop that loop from running. There are many other ways, I'm sure. That's the way I chose. And that tutorial that I got, here it is, instructables.com, Arduino servo motors. There we go, I did keep the link. So that's where you can go if you want to check out this particular tutorial that I used. And it just shows you the basic wiring diagram for the servo. And it is really easy. And in a sense, I think using the Arduino Uno does seem like overkill just for this function. Now, I don't know what prices are where you are, but here in Thailand, when I look on Lazada and I look at the smaller Arduino, it's almost the same price and often more expensive than this size. So I'm sticking with the Uno. I'm familiar with it. It's easy to use. I don't have to do any soldering. And that's my excuse. I'm not using the small one. The next thing to do is to open the Alexa app. If you're using Google Assistant, then open that one, Google Home app instead. Okay, but I can't guarantee that you'll have all the same features in the Google that you do in the Alexa. Okay, so click on that More button at the bottom and click on Routines, because what we're setting up here is not just one switch. Okay, in my case I've got 2 switches because I have another one for the computer monitors, and I suggest if you're going to automate your PC that you do the same thing, because you don't want the monitors or your speakers running while you're not home or while you're not in the office, if you're traveling, whatever. You want them to switch off. So I've got 2 smart home switches here, one to power up the PC and one for the monitor and the speakers. So I click on Routines and then click on the plus symbol to add a routine. Now I've already got them created, as you can see here, so let's have a look at what I've done. Okay, obviously it's too long for one mobile screenshot, so I've done 2 screenshots here. So I call this one Workstation Power Up, and the verbal command is Initiate Startup. Okay, now in my case I'm using the wake up word computer, but that doesn't matter, because when you click on here to edit the command, you're only editing this part here. You're not editing the initial wake up word. So if we look over here, the first thing I've got is my workstation. Now this is the switch that controls the monitors and the speakers. Okay, so that's what that handles. and that will power them on. Now this one here, this is the smart home switch for the Arduino and the robotic finger, shall we say. Okay, this is what actually turns the PC on. A nice little feature with Alexa is that you can really control what the responses are. So I've got say working, powering up the workstation. Okay, so that makes a nice little verbal feedback that is better than okay, which is what I was getting before. And it's a little bit more on theme as well. Then we have something that I only found recently. Is the wait function. So you can actually tell Alexa to wait before executing the next command. In this case, it doesn't need to be 5 minutes. I mean, 30 seconds would probably be fine, but I just wanted to allow the extra time just in case there's other delays. For example, if there's an internet failure between step 1 and 2 in this sequence, you know, I want to be able to allow for that. So I've said wait 5 minutes, and then it will power off the Arduino for starting up the machine. So it'll be switched off and out of the way. And that's really all there is to it. So it's a nice sequence of events. And also, if you are a Star Trek fan and you're using Alexa, in fact, fans of other shows as well, okay, you can actually add in there some Star Trek stuff. So I'm actually thinking about creating another startup sequence purely for demonstration purposes that also adds the bridge sound effects and a few other things in there, just for the fun of it. And that's really all there is in Alexa. I'm sure in Google Home you can do similar things. I have used Google Home. I do have a Google Home Mini downstairs, but I'm just finding that Alexa is far more versatile, far more suitable for this kind of task. And I am so happy with how it works. When I first posted on the RPF this build, someone commented that he could see a lot of this in my future, and it was that photo of Spock that I showed earlier. So here we are, we're underneath my workstation, and I'm going to show you now what it actually looks like live. Okay, so take the grill off. Mine doesn't fold like on the original TV show. I made mine just simply to pull out. There's some magnets. Okay, I've got some magnets in the corner. They're not terribly strong, but I've also got this non-slip material running along which holds it in there very nicely. Okay, so if we look inside, there is the unit up there. Okay, now I'm not going to run it right now because my PC is actually running, but just so you can have a look, see what it's like. It sits in there very comfortably, and I mean, the interior is still a work in progress. Obviously, I've still got more things to do, so I'm not finalising the locations of wiring or anything like that just yet. You can see there's the motherboard and all that. And I've got a 1 metre strip of LEDs that change colours. All the 7 primary colours that you see on the bridge in the original TV show. And up there I've got a speaker unit. So it's only a small microlab system, but in this box, boy, does it make some sound. Of course, there's the smart home switch on my UPS. That's really what I want to show you as well. I've got a UPS sitting there, smart home switch with the Alexa power supply there, running up into the box. So you can see here that there's the pins there, obviously on the motherboard, and the top pins there have the power supply. Sorry, the button input there, and they're joined elsewhere. In fact, they're joined right there. Both buttons going into this box here. There we go. That's what I want to show you. Just a little bit of a look inside here to see how I've connected it all up, but also to give you a bit of an inside look that I haven't really shown in previous posts yet. I hope you enjoyed this look at my project. Now, of course, you don't have to go the whole Star Trek theme with yours. You might be doing a PC gaming machine. You might be doing just an ordinary office desktop, and you just want to be able to start it up remotely or automatically when you walk into your office. Okay, you can use this same tech for that purpose, and maybe even your Star Wars build. Walk into your Star Wars basement or whatever you've got and command everything to switch on. Wouldn't that be cool? Okay, so whatever it is you're building, this is very versatile. You can use it for any kind of PC build, and I hope that if you do, please let me know. Leave a comment, leave a comment on the video. Send me a link to your project. I'd love to see what you've done. In the meantime, I will keep working on further projects. Coming up, I'm going to be doing a full desktop intercom cover for my Alexa Dot, so that it will actually look like an intercom from the original series. I'm also in the process of building a desktop control unit, because after all, every PC needs a push button to start it up. Okay, you don't always want to use my voice. Okay, there might be occasions where I put my computer to sleep and I just want to power it up with a push of a button. I want buttons to switch on and off display lights, that kind of stuff. So I'm building a desktop control unit that looks like one of the original desktop computers from the original series, but modified to suit my needs. Okay, so I'm not going to use the toggle switches. It's just going to be push buttons, and they're going to light up nicely. Okay, so that's coming up in the future as well. But of course, Christmas is coming, so I'm going to have a Christmas project, maybe two. Who knows? See you next time.